Example 2.4 is the last of our vector addition of forces examples. In this case, we have an applied force at the eye hook. We know its direction and its magnitude. The second force applied here, we do not know the magnitude or the direction, but we are told that the resultant needs to point in the positive x direction, and that F2 should be the minimum that it could possibly be. So we've got the example shown, we've got the setup. Let's continue by adding force 1. In this case, I'm going to use 80 millimeters to represent 800 newtons. I'll call the setup complete. So we know that the force is applied to the eye hook. And we know that the resultant has to go along the x-axis. So the second force has to go from the first force to the resultant force. So force 1, force 2 added together yield the resultant force. We know the direction, but we don't know the magnitude. And then for this blue line, which represents the second force, we do not know the direction or the magnitude. But we do know that we want it to be a minimum. And so we can see as we play with this line here that as I pull it out to the right, I get a longer resultant force, but that blue line representing the second force gets longer as well. And as I pull it over here to the left, again, it starts to get longer. Okay? So where that becomes the minimum is when that line is perpendicular to the resultant force. Okay? I'll show you. And this is the minimum value of the second force with a length of 69.2 millimeters, which would represent 692 newtons. We'll also have a resultant force of 400 newtons. So this concept will come up again where we want to minimize something. And quite often, that idea of minimizing a force will involve this idea of perpendicularity, so that all of the force is just getting us back to this horizontal. We don't have extra forces going side to side. All of that force is just returning us to this horizontal direction. And that is the solution.